Hello, I'm Ghazi Ul Muhtadi Mollik. My student ID is 222-63007, as you can see here. So if I come straight to the point, let's have a look at the word class. So what it does is in the init method, it initializes word with its string, and the frequency is actually set on default one, and an empty list for the neighbors. As we can see, there's a div. Uh, yeah, it's defined. And yeah, there's a lot of uh, getters here, like three getters. It returns the word, frequency, and neighbors respectively. And the increment frequency actually increases the frequency by one. The add neighbor method, what it does is it actually adds a neighbor string to the list, ensuring that no duplicates are added. And in the sort neighbors, we use the bubble sort, lodging in the sort neighbors. Um, so as you can see, there's no like built-in Python sort functions, and it uses a custom implemented bubble sort to sort the neighbors alphabetically. Yes. Um, and the IT, LEEQ, etc. These are actually defined to allow word objects to be compared based on their underlying word string. This is actually vital for sorting the main lexicon list later on. We will find out. And let's talk about these comment a little bit. So, yeah. So for the main build lexicon function, I chose a two-stage approach for efficiency. Initially, I use a Python dictionary like lexicon as state to read and aggregate words. Yeah, the word string is the key and the word object is actually the value. Dictionaries offer fast average of like O of 1 and then looks up and insertions, which is ideal for quickly updating frequencies or adding new words from the input file. So after all the words are processed, the word objects from the dictionary are transferred into a Python list. This list is then used for neighbor finding, sorting, and writing the output. So I've actually like created helper functions and built-in functions. Um, I structured the main solution using several helper functions that I mean. Let's have a look at the clean word function. This function takes a raw token and then it converts it into lowercase, removes like any non-alphabetic characters, and yeah, returns it definitely. There's a read words from file into dict function. It reads an input file line by line, cleans each word token, populates our lexicon as dict. It populates, yeah. If a word is already in the dictionary, its word object's frequency is incremented. Otherwise, a new word object is created and added. That's why. Here it is. Okay, so let's have a look at the populate all neighbors function. This function iterates through the list, and here it is. And what it does is to find neighbors efficiently, it first groups words by length. Then each pair of words of the same length, it checks if they differ by exactly one character. If they do, they're added to each other's neighbor list. Finally, it calls the word object word.sort neighbor. It's sort neighbors. Here it is. One word sort neighbors. Like for each word to sort its neighbor list using our custom bubble sort. Well, sorting algorithms. Well, the sorting algorithms, we can have a look at the insertion for sort for lexicon function. This is a standard insertion sort implemented to sort lists, word objects. And it's used by the hybrid sort for small subarrays. Like if we then there comes the hybrid sort for lexicon. So this is the main sorting algorithm for the lexicon list. It's a merge sort actually that switches to insertion sort when the subarray size falls actually like below a threshold, like yeah, which I've set it to 10. And it combines the O of log n efficiency for like the merge sort for large lists with the potential speed up of insertion sort on small lists. Well, there comes the, and then after that comes the write lexicon list to file. This is the standard insertion sort implemented to sort lists of word objects. It's actually used by the hybrid sort, like for small subarray. And yes, so like the hybrid sort for lexicon actually is sorry. All right. So it actually, well, the build lexicon function actually like, yeah, it is the entire process of doing it. Now let's have a look at the build lexicon. Well, actually, it initializes the dictionary to like an empty dictionary, lexicon dictionary main, and then it reads words into the dictionary using the, here we go, using the function that we built, read words from file into dict, and it actually converts the dictionary to a list of word objects. That is it. Here we go. Then it populates and sorts neighbors using populate all neighbors. Sorry for the comments. These are actually for like the assignment requirements. I know it's being a bit messy here. I guess I should have written it in a brief way, but yeah. And then actually the hybrid sort, you can see, sorts the main lexicon list, actually using hybrid sort for lexicon. And in the write lexicon list file, it actually like writes the result to file using write lexicon list to file here. Well, here I call build a lexicon. I'll run this now. Well, did I run the previous one? Yeah, I did. I did it actually previously. So everything is just on the run process, but I still run it. So Yes, I call build lexicon. I'll run yeah, like this with like s1.txt. Where's the s1.txt? Oh, whoops. It's actually s2. Anyways, the s2.txt to demonstrate, and I'll actually show the outputs here. Okay. And here's the timing cell for like building lexicon. For the larger in.txt here, like if I run this again, there's gonna be a difference, of course. Where isn't it running? Come on, run, bro. Okay, we just saw it like maybe 14.4044 probably. Run, bro. Okay, here's a yeah, 14.48 seconds across two runs. So yeah, here's the timing cell for build lexicon. For the larger in.txt, efficiency is the key. And for s1.txt, the time is very small. And later on here, next I implemented a skip list data structure. A skip list provides of like log n average time for the search, insertion, and deletion, as we know that. So in the skip node class, represent a node holding a key. What it does, imports the random module first, and then a value like and a list of forward pointers of different levels. The skip list class actually like here, it initializes the header node and sets the maximum probability factor. And in the function get random level for new node, what it does is determines the height of a new node probabilistically. So there's an insert function as well. What it does is, this is a key method. It first searches for the correct position of the insert. The new key was texting. Sorry, I'm sorry. Position, insert the new key. If the key exists, it increments the frequency of the associated word object. I'm sorry. Um, and sorry. So actually in the insert, um, this is a key method as we said, increments the frequency, yeah. And if not, it creates a new skip node like, and then it with a random level, and it links it to into appropriate levels of the list. In this process, it maintains the sorted order. Um, you can see it. And in the search method, yes, it actually traverses the skip list from the highest level down to a finding key, returning the associated word object it found. If it doesn't find anything, it just returns none. And this function, what it does is this method, it actually traverses level 0 of the skip list to retrieve all word objects in sorted order, as the list inherently maintains the order. So, and there comes the last but not the least function, display list structure. So sorry, what it does is just a second. Well, actually, display list structure, like it can be mentioned as a debugging aid, I should say. It's sort of like an optional method that I created. It's not a mandatory method, it's just to debug if anything goes wrong. That's it. Well, the build lexicon skip list function uses skip list construct to construct lexicon. Instead of like Python dictionary words read from file directly inserted into skip list, if a word is new, a word object is created and inserted. If it already exists, its frequency it's incremented. After reading all the words, get sorted word objects, retrieve the word, uh, retrieves the word objects as a list, which is already sorted alphabetically. And yes, alphabetically by word. I'm so sorry. Okay, and in the end, it actually populates all neighbors here. Actually, the same helper from the main solution, I guess. Yeah, it is used to find the sort neighbors from the skip list. And then finally, our write lexicon list to file, like writes writes the lexicon to the output file. That's it. Let me run it. Ran it already, but still I'm running it again. I'll run build and lexicon skip list now with S1 text. Run it. You can see it. Well, and later on, here's the timing cell for the skip list version. If I run it, you can see it's only average execution time 0.01 second across 2 runs. So yep. Well, now for the comparison based on timings of like S1 text, both solutions appear to perform very quickly, like registering as 0.00 second already. almost. So this is like expected for small files. But however, for larger data sets, like in.txt, I would anticipate my main solution, a dictionary plus hybrid sort, probably, to be faster than the skip list solution implemented in Python. The reason is, reason for this expectation actually. Well, Python's dict is highly optimized. It's implemented in C and offers very fast average of one insertions and lookups. This is actually very beneficial for initial word aggregation phase, but yep. So actually both solutions correctly build the lexicon and like to the assignments constraints, I hope everything's met, including the use of customs sorting algorithms. Uh, the main solution is actually optimized for efficiency on larger data sets using dictionary and hybrid sort, while the skip list implementation provides an alternative approach with logarithmic average case performance, but like if I say potentially higher constant factor overheads in Python for like this specific task. Yep, like that's it. Thank you for watching. Yep. So if I stop it.